Hello friends, welcome to my channel and explore the world of Microsoft Azure. My name is Rajneesh Kaushik and I'm a Microsoft certified trainer, consultant and an enterprise architect. For more latest videos and blogs, you can always log into my website rajneeshkaushik.com and subscribe to my blog. Please do not forget to subscribe my channel and click the bell icon so you don't miss the latest videos. Do like, share and comment.
In the world bustling with data, control is not just a luxury but it is a necessity. Welcome to my channel where today we are unlocking the secrets of advanced data controls within the Databricks. In this episode, we are going to dive deeper into the Unity catalog from the robust fortification of row level security to the surgical precision of column level masking. We will explore the topics like managed data sources. We will unearth the magic of secrets of delta sharing. We will reveal the magic of automated lineage for all your data sets. And we will explore it and dive deeper into these concepts to make it more easy to understand and clear. So let's buckle up and get ready for the journey into the heart of Databricks Unity Catalog. Unity Catalog unlocking advanced data controls in Databricks. Let's see the agenda. Here is the agenda. First, we are going to learn row level security and column level masking. Then we will jump to a topic for managed data sources and external locations. Then we will understand how the default access to the storage by the catalog or schema is done. We will understand how do we govern the file systems and objects differently. We will understand the access the data from a specified environment only because there are chances that you are trying to access the data from a specific set of environments. How do we do that? Then we will learn about automated lineage for all your workloads and how the lineage concept works. Then we will dwell deeper into the search and discovery capabilities within the Unity catalog. And then finally we will jump to the discovery tags and then we will close the session after understanding delta sharing and how the delta sharing works under the hood. Row level security and column level masking. So this functionality is used to provide a fine grained access to the data sets. So let's understand the row level security. Row level security is used to filter a specific set specific rows, okay, based on some conditions, right? For example, if suppose you want to make sure that if you belongs to the admin user group, then all the rows of the table is displayed. But if you are not admin user, you belongs to developer or you belongs to some other user group, you want to display the rows on for a specific region, you want to display the rows, right? Suppose in this example you want to constrain the rows for admin user, you want to display all the rows, but if you are not admin, then you will display only the US rows, right? The region equal to US, that those rows you want to display. So it is very simple to create this kind of row filtering. You will create a function and you will assign that function to the alter table statement. So in this case, alter table sales table, set row filter the function name which you have created on region. So that means on the region you will use this function and based on the region you will filter this condition. So in this case the filter condition is region equal to US. So it will filter the region equal to US if you are not admin group, otherwise it will display all the rows. Now let's come to the column level masking. Column level masking is used when you want to mask the column based on the sensitive column like PII column. One example is SSN. SSN you don't want to display to all the users. So if users who belong to admin group, you want to display only those users all the SSN number digits. Other users you want to display only star, right? Or you want to display last 4 digits of the SSN number. So in that case, what you will do, you will create a function again, SSN mask function, and in this you will provide a condition. Like in this example, if you are a member of admin group, you will display SSN number as it is. Otherwise, you will display the star 4 times. and then the same way you are going to use the alter table statement, and in that alter table statement you will use the alter column, and alter column you will use the name of the column, which is a table SSN column, and then you will put a set mask. Set mask, you are going to put the name of the function, SSN mask function, which you have created here. So this way, when a user belongs to admin group, he will be able to see the SSN number as it is. But if you belongs to other group, then you will the SSN number will display the star. So manage data sources and external locations. So here we are going to understand how the Databricks evolved from the traditional Hive Metastore model to the Unity Catalog model, right? So in the legacy Hive Metastore, traditionally what we used to do, we used to use the cloud storage like S3 or Azure ADLS Gen 2, right? And these storages were configured at the cluster level, okay, or a data warehouse level, and this is done by the user identity pass through mechanism. That means user's identity is passed into that to access the cloud storage. And so these credentials which is stored, it is shared within the cluster or tied to a individual user identity. This makes it very complex for the managing this access, because it is a per individual user access and all these are tied to a cluster level, right? So what Unity Catalog did is, Unity Catalog introduced a credentials as a first class object, and in that credentials has its own access control list, and these objects are stored in the metastore. So these credentials are not directly used by the end users, but it is actually consumed by the Unity Catalog, and this is a backbone of your access control. Now, what is a managed data sources? If you see in the diagram, the managed data source. So whenever you set up a Unity Catalog Metastore, you associate with a managed data source whenever you set it up, and this is nothing but a specific container or a bucket in the cloud storage. So what happens in that is, if this particular data is exclusively accessed through the Databricks, right? And why? Because it is ensured a secure and a controlled data environment. So this default credential object is established alongside the managed data source to facilitate the controlled access. That means with that data storage, there is a credential object already created, and that with the help of this credential object along with the managed data location, which makes it a full package to access the data source. Now, what is a data storage and a managed table? So what is a managed table? If you remember in the legacy Hive model, whenever you create a table without specifying a location, in that case the location is default to the Databricks file system, and these tables are called managed tables. Unity Catalog actually retained exactly the same concept, right? And whenever you don't specify a table location, it is actually by default understood as a managed table which is linked to your metastore, right? And apart from that, it also enforces that this managed table should be a delta table, which means with the help of delta table you are leveraging the optimized data storage for reliability and performance, which Databricks provides out of the box. Now then, what is the external location? Unity Catalog again introduces a very unique concept called external location, which pairs the cloud storage URL with the specific credential. So it can be any cloud storage URL, and then with that you are adding a credentials. And these are the distinct, these credentials are a distinct object which has its own ACL, and this helps users to perform the actions like read, write, or creating a table. So this way, it facilitates the secure access to the arbitrary sets of files in the cloud, and this allows you for greater flexibility and federation of the data. Now, how can I federate the external tables in my metastore? This is one of the questions which is being asked day in and day out. So in that case, if a user has appropriate rights, okay, to create a table in, and these tables are external tables, which is a tables located in a storage location, right? Then you can use this location in the metastore hierarchy, and this table can support different kind of formats like delta, parquet, avro, orc, and all those formats. So this way you can federate the external table to be accessed from the metastore hierarchy and then access it as if it is first class object. So this way Unity Catalog streamlines secure data access by abstracting the credentials and access control into a discrete manageable objects, and this way it actually provides a fundamental shift from the more rigid and potentially less secure method of the past to the fine grained control of the data at a very low level abstraction, both safer and more convenient for all the users. Default access to storage by catalog or schema. So this concept is very important because how this manage data sources for data isolation or cost allocation is created. So let's understand this. At the top level we have a metastore, and after that we have a catalog. So for one metastore, there could be multiple catalogs, like in this example, catalog 1, catalog 2. And within that catalog, there are multiple schemas like schema 1, schema 2, schema 3. And for each schema assigned to a manage table, right? So at the metastore level, you can assign the manage container or a bucket. And then at schema level, you can also define the manage table, right? So at any level, either schema, catalog or metastore, you can define the manage container or a bucket. And then based on that, you can isolate the, do the data isolation. Like suppose you have given a catalog 1 for department 1, catalog 2 for department 2, for accounting department, for finance department, and then you want to segregate their schema and then manage table. Their location is also segregated separately, and then you want to make sure that cost associated to this particular part of the container bucket is assigned to the finance department, this particular part is assigned to the accounting department, this particular part is assigned to the HR department, and each department has their own catalog and then they have a different schema. So this way you can do the data isolation and then you can attribute a cost associated to a particular department, and this provides you a best practice of isolation. So Unity Catalog provides a unique feature of governing the file systems and objects completely different or distinctively. So how does it work? Suppose in this example, user wants to write, tries to write on the files. So Unity Catalog has a access control list for each user, and it understands that if a user wants to write, so suppose the write is coming for the external location, where the external locations could be any volume. So it can grant the read or write permission to that external location volumes, right? But if suppose the same user wants to write on the table or the data which is kept in the cloud storage, in that case it can give you a read or a select only operation, right? So in this case, writes to the table or table data via a path does not use the write permission from the external location. So that way it is only selecting the data, you can only select the data, but in case of volumes you can read or write the data. So this way you can govern the file system separately versus the data object separately. So this unique capability is the game changer in the Unity Catalog, because it gives you idea of accessing the volumes as well as accessing the tables separately. Unity Catalog provides the access data from a specific environments, right? So like let's understand this example. You have one metastore. In the metastore you have a catalogs, and for each catalog, like in this example, dev, staging, prod, and then the catalog could be also assigned based on the business unit level. So in this case, the business unit 1 dev, business unit 1 staging, business unit 1 prod. So the catalog could be defined based on the environment dev, prod, QA, or it could be based on the business unit. Now further to it, you create a workspace which is nothing but a Databricks workspace. You assign that workspace to a particular catalog. Like in this example, dev catalog is assigned to the dev workspace, staging catalog is assigned to the dev and staging both, prod is assigned to the prod workspace, and dev and staging workspace, business unit workspaces, business unit catalogs are assigned to the dev staging workspace, right? Now further that you create different groups like developer, tester, analyst, BU, and based on that groups you assign the permission to that particular workspaces. Like in this example, developer have access to dev and staging, only dev, but and even staging workspace also developer have access. Testers have access to the prod as well as staging. Analyst only have access to the prod, and BU developer and BU tester have access to this workspace, and BU users have access to only the prod workspace. So this way you can neatly define the access to the data, and availability of the data can be isolated across the workspaces and the groups. This is a very neat way. Now if you want to add a developer, you will just grant a developer the specific group, and then the person is added to the group, he will automatically be granted that permissions which is required, right? Prior to that it was very difficult. You will only have a permission on the workspace level, and then very difficult to manage that. Let's understand the life of a query with Unity Catalog, how the query in the Unity Catalog works. So the first step is that user fires a query, and that query could be in the SQL, Python, R or Scala, and then that query hits the cluster or a SQL warehouse. Then the cluster or SQL warehouse actually sends this query to the Unity Catalog for checking the namespace, metadata and grants, which means that this query represents which namespace this query will be executed, and which metadata will be used, and what are the grants, that means the access required to execute this query. Now in Unity Catalog, which is managed by admin person at the time of setting up the metastore, he creates a IAM role. In AWS it is called IAM role or a managed identity in the Azure. So when you set up the metastore, it creates this IAM role for AWS or managed identity in the Azure. Admin user also creates a storage credentials or external location in the Unity Catalog, and based on that it also defines the access policies in the Unity Catalog. So now you have already set up these things. Now when somebody wants to check the namespace, metadata and grants, it is already set up, and based on that it is going to assume the IAM role which is set up here. That role will be assumed, or the managed identity role will be assumed, because you are accessing the data from the metastore, and that data have some credentials, and those credentials are nothing but a managed identity in the Azure or IAM role in the AWS. All the operations are audit logged in the audit log table, right? And then based on that IAM role, the access is so once this access is assumed as a IAM role, then it returns the list of path, data files and scope down temporary tokens. So it returns the list of paths where the access can be granted, along with the data files where the access can be granted, and then it scopes down the temporary token. It gives you a temporary token which is valid for 1 hour. Then once that temporary token is given, it goes to the cluster or SQL URL, a SQL warehouse, and SQL warehouse actually sends this request the data from the path which is given to it, or path or data files with a temporary token. So it grants a temporary token and it sends it to the cloud storage. Once the temporary token is given and the URL is given for the cloud storage, and that URL actually provides a shared access signature in the Azure, right? With the help of shared access signature, you can access that cloud storage, and then that access is granted, right? And based on that access, the data is actually returned. Now the data is returned, but that data contains everything. Now at the cluster level, it is actually enforcing the policies which data need to be displayed to a user or which data need not to be displayed to the user. So those set of policies are enforced here, and based on that the data is filtered, and then that filtered data is sent as a result to the user. So this is how the whole life of the query with the Unity Catalog works. Automated lineage for all workloads. So Unity Catalog provides end-to-end visibility into how the data flows and consumed in your organization. So how does it do that? it actually auto captures the runtime data lineage on a Databricks cluster or a SQL warehouse, right? It actually tracks the lineage down to the table or a column level lineage. And when you try to see the lineage, it actually leverages the common permission model from the Unity catalog to understand what kind of permissions you have to see the lineage, right? I mean, if you don't have access to a particular table and there is a lineage from that table happening, then it may not show you that lineage graph, right? So it provides you unique capability for putting a lineage across the tables, different dashboards, workflows, notebooks, feature tables, files, and DLT tables. So this way it covers almost all the objects in the Databricks, where it is important for you to understand the data lineage. So now let's understand how the lineage flow works. So let's take this example that you have a ATL job, or you have some ad hoc users which is trying to access the workspace cluster or SQL warehouse, or a DLT table which is actually accessing the data. So when a code, or in any language, whatever language is supported by Databricks, is submitted to a SQL warehouse or a cluster, or DLT executes a data flow, that is where the lineage service comes into picture. Lineage service actually analyze the logs emitted from the cluster. So whatever logs are emitted from the cluster, it is actually analyzed by the lineage service, and it pulls the metadata from the DLT table. It actually takes the data from the DLT table, and based on that it assembles the column and the table level lineage from this metadata, and based on that it creates a table and column level lineage, and that column level and table level lineage is created and pushed into the table. Now whenever a user tries to explore the lineage, the same information is kept, which is kept in the table, is actually displayed in the UI. And the same way, if you are using Alation or Microsoft Preview or Colibra, these are the external tools, the same table is being used to pull the data from the Databricks and display it in these tools. So these are the visualization tools. These are presented to the end user graphically in the Databricks. Lineage can be exported via API if you are trying to call the Databricks via the API to filter or fetch the lineage, right? Or you can import it into the other tool, like these are the tools. So this is how the lineage works end to end. Built-in search and discovery, and Unity Catalog provides you a very nice way to use a search and discovery of your assets, data assets, and this does it in a very low latency mode. So it provides a very nice UI for searching your data assets stored in the Unity catalog, and it also provides a unified UI, one UI for all your data science and ML workspace, as well as Databricks SQL workspace, both the workspace in a unified way, right? So if you see this in here, it is tables, queries, dashboards, alerts, everything is searchable, and it provides a common permission model from the Unity catalog to access this. So this way, if you search a particular value, which is nothing but a semantic tag. Semantic tag is a very business specific tag, right? To filter the data, and this tag you can search across the different data sets, right? So you can apply that semantic tag to data and search across the tags. So like for example, in this case it is a customer. So the moment you say customer, it actually gets the value from all the tables, okay, where the customer column is given, and it gives you those names. So semantic tag could be, one example is that if suppose you have a one table which contains a book publication date, so then that you can tag that particular column with the year of release, right? So that could be your semantic tag. And if you want to you know that this tag could be repeated in many tables, because this column is common across many tables, and you want to search that, so you can do that search with the help of semantic tag, which is here. and that will help you to search it across the different tables. Okay, so what is discovery tag? Discovery tag is actually, let's understand it with the help of a problem. So if you try to search data assets in the business terms, or you try to search it with a generally agreed taxonomy, right? In that case, you require additional tools, right? So the solution to this kind of problem is to create a discovery tags. Discovery tag is a tag which allows you to tag a column, you know, or table or a schema or a catalog objects in the UC, and that particular column table can be tagged with a different name. Like in this example, if you see, there is a PII data and sensitive data. This is a tag given to a specific set of columns or table names, right? So the moment you provide this discovery tag and you search this discovery tag, it will give you all the tables which contains the PII data and a sensitivity flag. So that way you can specify this discovery tag and search with the help of the discovery tag easily. So this makes your life simpler, and you can use the agreed upon taxonomy and search the data in no time. Now let's understand it a little bit more granular level, the same concept, how it works under the hood. So again, data sharing is a protocol, open source protocol, and actually client authenticates to the sharing server. So here this is a data sharing server, and it is exactly the same data sharing server which is depicted here. So now we are understanding it more deeper. So client authenticates to the sharing server. Client requests a table, right, which includes all the filters inside it. Server checks the access permission. Server generates and return a pre-signed short-lived URL. This is a pre-signed short-lived URL, and client uses the URL to directly read the files from the object storage. Now sharing happens on delta part files, supporting full table partition, delta versions, etc. So all these things are happening here in the delta share. Client is system independent, just needs to be able to read Parquet file. That means client could be any of these client, and it is system independent. It is just accessing that Parquet file. And in the Databricks sharing server and ACL checks are integrated with the Unity catalog. That means all the sharing and checks and access control and everything is done under the hood with the help of a Unity catalog.
Thanks for watching, and do not forget to subscribe and hit the bell